I'm South African, but I live like hour and change north of Montreal. So I want you to imagine you come to visit me. I go pick you up at the airport. We drive up north. As we enter the Laurentians, I tell you I have this kind of like fascinating experiment I want to do with you. And we veer off into one of the little Quebecois forests. And the good news is it's September, so the bugs have died down a bit. And I give you a radio and I say, all I want you to do is sit in this little hide. And if you see a deer pass by, simply just radio me and tell me that you've seen a deer. And you sit there and lo and behold, a few minutes later, a beautiful stag walks by and you radio in and you say, hey, I see a deer. The experiment's not done. You continue to sit there. And a few moments later, another deer walks by. But actually, this deer has a giant bushy mustache. Now, even though it's got this kind of like crappy disguise, hopefully you saw right through it. And I would expect you to still radio me and say that you see a deer. And then maybe you'll say something like, yeah, it's rocking a tash. Haha. All right. Let's run this exact same thought experiment. But this time now, instead of you, we're going to swap you out with a pattern matching machine. And I don't mean a neural net transformer based. It's not a model LM. It's good old fashioned deterministic detection signature. All right. It's a pattern matching machine. We put it in the hide, same job. A deer walks by, it lights up, and it says that it sees a deer. Exact same story. A few minutes later, the bushy mustache deer walks by, and this time, nothing. Crickets. What's walking by isn't really matching exactly the pattern it's trying to match on, right? So the problem is essentially that it's looking for deer. It's not looking for deer and its derivations, variations on the theme of deer. And so now you can tell me, well, Faan, that's a very easy fix because all we need to do is relax the detection criteria. Let's detect deer and its derivations. Deers with 12 legs and purple hair and afros and beards and mustaches, everything. But the main thing about that is that kind of arguably introduces a worse problem, which is, it introduces a lot of false positives into the system. Shout out to Rob Lee from Sands. I totally stole that thought experiment from him. I just love it so much, so I use it every opportunity I can. I think it just beautifully encapsulates the kind of fundamental tension at the heart of alert-based security between being too strict or too relaxed. When you're too strict, it's brittle. It misses slight variations, a lot of false negatives, right? Things slip through. But when you're too relaxed, too promiscuous, yes, you're getting your true positives, but it's mixed in with a whole mountain of, you're getting your true positives, but there's so many false positives, so it's hard to even get to them, right? Another way I think we can frame this is that alert-based security is low resolution. So let's just consider this to be the archetype of what alert-based security looks like. There's obviously many variations. We have our raw telemetry forwarded, it's deduplicated and normalized, it goes into a lake. We have detection signatures, right? Binary matching on it. If it matches, it alerts, and then typically human analysts will come in the end and review. So if we just focus on the alert part, when I say it's low resolution, I mean it's Boolean, right? It's going to either not alert or it's going to alert. But conceptually for us, there actually exists a whole lot of variations between these two, right? For the human, there's like something feels off. Let me just quickly check something, all these kind of things that can be the initial breadcrumbs that ultimately lead you to one of the conclusions, but don't quite fit that mold right off the bat, right? The thing is about all these things is we could say, at least traditionally, right? Just kind of connecting with David's talk a bit. Traditionally, we can say that this is kind of like the purview or the domain of human judgment, right? It's not our pattern matching machine that's going to have this like little intuitive call, right? So perhaps a somewhat contrived and roundabout way that we can define threat hunting or think of it, again, in the traditional sense is when we have human judgment involved in the detection process itself, not just in reviewing its outputs. And I don't want to sound like a fanboy, but I would be remiss to mention that the goal of threat hunting, I just want to like drive this point home, isn't just to find threats. I really think peak is kind of one of the most important conceptual evolutionary contributions to the field, especially in redefining what the goal of threat hunting is. Finding threats is the path or the method, but even when we don't find threats, finding missing telemetry or detections or misconfigurations, all these things, we're actively always driving improvements in overall security posture. All right. So I sang the praises. I said how awesome threat hunting is, human judgment works so well. We catch the deers with mustaches. So threat hunting is about 15 years old. Then the question is, why is it still seen as a luxury, as kind of like the proverbial gravy? Why is it not the meat and potatoes of security systems? And the real thing, David also alluded to this a lot, is it's like a Sisyphean task, right? The amount of detection. Yes, it's great to have human judgment involved in detection, but that is a extremely large, ever-growing, increasing perpetual demand. And human judgment, carbon-based life form doesn't have a Moore's law, right? So we can get it a little bit better, but we can't really dramatically scale our judgment. So it just doesn't match the scope of the task. But my core thesis is essentially that, you know, we can actually now dramatically scale human judgment through the intentional integration of an agentic layer in a threat hunting system. And this is kind of like what I've reoriented my entire professional and to an extent personal raison d'etre. This is what I study and think about and work on and teach full time right now. But I think we have to unpack intentional integration. This really connects to what David and John were just speaking about. It's about the not using a hammer, not seeing everything as a nail and just using a hammer, right? We know intuitively humans are good at some things and not that good at other things. We know intuitively good old-fashioned deterministic code is good at some things, not that good at other things. I want you to consider, any kind of transformer-based intelligence or LMs or AI, whatever you want to call it, as its own distinct third entity. It has its unique sets of strengths and weaknesses. So when we look at our overall security system, we're very intentional about where does it confer a unique benefit, integrate it there. Where is good old-fashioned deterministic code better, which is the majority of the time, not involve it there, and also design in a way to maximize strengths and minimize and mitigate weaknesses. If you know there's a chance of hallucination, if that hallucination can cause a serious problem, then you have deterministic gate checks there to make sure, right? Just as a simple example. Great, so now how do we do this? Well, I teach a system of applied harness engineering. I don't teach a specific ABC Faan's ABC method that I want you to ham-fistedly put like replace your current security operations with. It's not a specific tool or application. What I really want to kind of teach people are the 9 fundamental systems with which to approach this question. How do we intentionally integrate an agentic layer in your defensive security posture to do it where it adapts your own system, right? Now, this is a model. I've broken it down into 9 topics. Like all models, it's a little bit fuzzy. It's the map and not the terrain. And so there is sometimes a little bit conceptual overlap and stuff, but ultimately the goal here is to make sense of what could otherwise be a overwhelmingly complex field so we can grok it and you can understand exactly what might apply to you and what might not, right? I'm going to go through each of these in turn. The first one is really about what David and John mentioned too. This is kind of like personally for me one of the most interesting things. And it's all to do about how do we deal with this layer where, as David said, you can't just you can't do an API call to a model and say, here are a billion events, find bad stuff. There are many, many reasons that doesn't work at all. It's inefficient and ineffective, right? High latency, high cost. But also, despite the fact that you can overflow and compact the context, which is a lossy process, We know about ideas like lost in the middle or the dumb zone or context rot or spurious correlation, the Texas sharpshooter fallacy. What it all boils down to, and this is why we have this idea of progressive disclosure, is that agents aren't really good when you give them too much information, and especially not if that information is not relevant, right? But even more so, I said, what are agents good at and not good at? You cannot give an agent like a million conduct log entries and you ask it, hey, is beaconing taking place? It can't token predict the answer, right? It's not in its weights, the answer to that. It can recognize it needs to do statistical analysis. It can go online, research, write a Python script, run that Python script and get the answer, right? But it cannot just, it's not a number crunching machine. It doesn't work like that. So I've seen now a number of approaches to deal with this. Here are six, there are more. I just find these are kind of the primary, most interesting ones. And they roughly operate on two axes, whether or not it's preemptive or on demand, and whether or not it falls kind of in the category of, I would say, detection versus query versus statistical analysis, right? The first one that I landed on just because of I used to work for active countermeasures and I was kind of inspired by what Rita does. And that is to do statistical analysis on all the telemetry along certain dimensions. So a good example would be like C2 beaconing to create signal, right? We're not trying to match, we're not trying to say yes or no. We're trying to assign value probabilities so that we can sort according to a CLI to say this is the most likely to be beaconing and this is the least likely, right? Uh, Obviously, anything you do preemptive has a cost associated with it, but what I do like about it is that you can then use those results as part of your hypothesis generation. It doesn't just have to be intel and past hunts, it can be the shape of the current telemetry and where probabilistically we think there's a high chance of something occurring can be part of the generating of the actual hypothesis. Now, Roberto Rodriguez, I think he's goes by Cyber Warthog. Somebody I really admire and consider one of the kind of most interesting and pioneering thinkers in the field. That's a really good talk he published recently. He does something similar, but instead of doing preemptively, it's on demand. So he uses Jupyter Server sandboxes to run specific analysis or query. But like I said before, we don't really necessarily want the agent to figure out to run specific data analysis every time and do research and write the scripts. We want to standardize that. So you standardize all those tooling that they can use on demand following the generation of a hypothesis. Very similarly, using queries. And then one of the big fields, I think I saw a headline somewhere saying like this is going to be a $1 trillion industry within agentic security itself. But in the words of Mugatu, so hot right now are these knowledge graphs, right? And I'm sure some people are going to speak about this today. But knowledge graphs is just really a very efficient way, you know, and a lot of us know about it in security with Neo4j and Bloodhound and things like that, to really elucidate the relationship between different data entities. It should be very clear why that is important to security, right? And so people like Google's TimeSketch Sec Gemini, all telemetry is pre-processed into knowledge graphs before the agents deal with it. Another one I find interesting too is if you can imagine you get your Intel feeds, you parse IOCs, and then you have agents immediately write Sigma detection rules and run that against your lake. So you've just dramatically reduced the friction from here's Intel to run a query on your data. Perhaps more in the realm of SOC, but I also thought this was an interesting approach to not just go jump into the telemetry head first, right? Shared states. Now, every single time I do an API call when you're on Claude Code and you chat, you're sending text. The model, all models ever do and can do is receive streaming tokens and give back streaming tokens. You send text, you get text back. Even when it runs a tool, that's just a JSON request for the harness to run a tool. The model can't really ever execute a tool. It asks permission, right? Now, if we were to orchestrate a hunt and we have many of these API calls that are running in parallel and each of them find something, well, how are we bringing together all the different findings so that it's available for a separate agent, a separate API call in the future, right? There's a whole bunch of different ways to attack this specific problem, but I think again the kind of winner here is once again graph rag or knowledge graphs, really kind of more broadly, because uh, whenever you care about connections between data, between information, this is kind of like what knowledge graphs are for. And that's the talk with the guys from Google speaking about how they use it for their threat hunting program with TimeSketch and SecGemini. So as hunters, we love our tools. We have a whole lot of different tools, and you can imagine, of course, if you want agents involved with your hunting, you either want to task them and ask them to use a tool, or you have automated workflows in which they need to be able to use tools as well. Now, like I already said, models can't really use tools. The harness executes tools. It does the Win32 API call, but an agent, a model can ask the harness to do that. Now, there's a few ways we can do that. When you create your harness, any inline function you can create in your harness, you can expose to the model. We know models are really good at CLI use, right? A very short self-corrective feedback loop. And then often we want to use another tool. You want to use your Velociraptor, and then you can do API calls. You can either write the inline functions for those API calls. A more flexible and popular approach is actually using CLIs for API calls. And then if you really, really wanted to, I guess you could also use MCP. GUI automation is kind of classically seen as something expensive and slow and brittle, but it's definitely becoming better. And there is a company called Legion that their whole kind of unique selling proposition is a dramatically decreased transitional tax going from humans to agents by having the agent shadow you, learn how the human clickety clacks on the GUI, and then the agent will just kind of do that. So they train how to use the GUI like you do. Orchestration, now again, if you're just working on Claude Code, perhaps some of you have seen it. Okay, it'll dispatch sub-agents, but most of the time it's a sequential manner, right? You ask something, it speaks back, ask something, it comes back, right? Now, if you start scaling, you want to sometimes, not all the time, move away from that pattern for two main reasons. Imagine you have 5 tasks that are completely independent. You want to parallelize them just to reduce the latency, right? Other times, Troy spoke about this, about having models check each other. There's a design motif called the maker checker, sometimes LM as a judge, where you essentially, especially when it's very important kind of keystone decisions, you want another model to review the output. And it's almost like using a model as a gate before that decision cascades and has effects elsewhere, right? So using multiple agents in a specific workflow that can include gates to confer a specific benefits. Skills, so skills, everything else I mentioned is supportive structure. It's accoutrement. It's really to unlock the ability. Where do you hunt? Where do you define how to hunt? What the procedures are? All of that. That's really based on skills. I view them in many ways as the kind of evolutionary progression of prompts. It's where we concretize what's often kind of fuzzy, tacit organizational knowledge. It lives in the minds of the hunters and some of the applications and maybe little lists. Daniel Miesler also speaks about this a lot in kind of a more general sense, is this is really our opportunity to create SOPs and really clearly define what it looks like, right? Skills are really magical. They're markdown files with YAML front matter, which is, deceptively undersells everything you can start doing once you build up a library of hunting skills. Because yes, you can execute them, you can automate them. If you're ad hoc prompting, you can't really automate. And David spoke about this too, is you don't tell an agent, go find bad stuff, right? You have a hypothesis that C2 over HTTPS could be happening on this specific subnet. Here's where you define your very, very specific. This is how you hunt this specific thing. These are the telemetry sources. These are the processes. Here are the tools available to you, etc. We can compose them. We can combine different atomic units to be different hunts if we want to track across MITRE tactics. And this is a much better approach to scaling as well by having many different atomic API calls and not giant monolithic API calls, right? They're captured, so we evolve them, we A/B test, we make variations, we A/B test them, and then we can version control them, and we can share them with our colleagues, we can share them with the community, and it also allows us to create conditional logic. If you find this thing, then do these steps. If you get this kind of results, then run this script that I've packaged in this directory to look for something else, right? It just opens everything up for us when we start concretizing our hunts as a skills-based system. LMs are kind of trippy in that it's a flat file with a whole bunch of like trillions of probabilities inside of them, and they know a lot, right? But it breaks down in two key areas. The first thing is it's a few months behind, but the bigger thing I think for us as threat hunters or defensive security is that hopefully it wasn't trained on any knowledge specific to your network, right? And there are so many things that we can answer that we require by looking at specific organizational context. Who's on what network, who uses what host, what do we expect, what tools do we expect them to use, where are our crown jewels, etc., etc. We want to have that additional layer on top of just, I think this is beaconing, I think there's a hash hit on this process, etc., right? There are many different forms, again, from RAG to DuckDB, but different form and function. So different forms are for different use cases. But context engineering is the field that I think about how to approach organizing that so that at inference time or runtime, the model always gets the information that it needs. Feedback loops is really kind of under the umbrella of skills, but I wanted to give it its own thing because it is the intentional reflection back about how the system itself can improve. Strong connection to the peak metrics. Again, any missing detection, any missing telemetry, any misconfigurations. After a hunt, no matter what happened, another agent will look at everything that happened and ask these series of questions and come up to suggestions for the humans about things, improvements they think we can make to the system itself. Now, evals, when we make these changes, or maybe we want to cost optimize by swapping one model out for another, we need to have ways to quantify whether or not the system has improved or degraded. We have to go beyond the pure vibes of it. Evals is what allows us to do that. And finally, adversarial resilience, as David said a lot in his beginning, is, introducing an agentic layer, you can't skirt around the fact, dramatically increases the attack surface. It introduces distinct new attack vectors into your system, right? So you have to account for this, and you have to have ways to mitigate this beyond just guardrails. You have to have architectural controls. I obviously don't have time to jump into this, but this is a great talk that I saw recently on this. So things like dynamic capability shifting, right? Where you match what the permissions are with what you expect that specific API call to be allowed to do, right? So these are the 9 fundamental topics of applied harness engineering for defensive security or threat hunting. Obviously, really what I had time for today was to quickly give you a sense of what it is and hopefully some idea of why it's important. And then if you are interested in the how, if you want to get some hands-on experience, you are in luck because in 9 days from today, as part of the Threat Hunting Summit, I will be doing an entire 8-hour course on this topic. And I really hope to see as many of you there as possible.